I'm excited to talk about this topic, mainly because, I joined the Army. I graduated from West Point in 1998, and I was a ham operator in high school and middle school. And when I decided on what branch I wanted to go, there's this branch called Signal Corps back in the day. And so I as a computer science major, I had various officers tell me various things about how to choose a branch and what's important. But I think what drew me to Signal was because at one point someone said, if you really like communications, then you want to do that. And so I thought about it, and I was like, I already know Morse code, because back in the day you had to learn Morse code for your general class license, so I thought, oh, I'll just do that, and then I'll already be a leg up when I get there. And oddly enough, the Army equipment, as you'll see in my presentation, is it's kind of what I'll use the term soldier proof is what we use, which is basically it's you don't put a lot of thought into the radio side. You just turn it on and you make it work based on the instructions you're given. So I remember at one of the first exercises, they were saying that they were having trouble, and I said, well, I was like, what's the SWR on your antenna? And they looked at me like I had a third eye or something. They were just like totally confused. And it's ironic now that all of the things that kind of went away with HF when I was just starting out in the Army are starting to come back. And that's what my talk is about today. High frequency renaissance in the United States Army. There's probably varying levels of what people know about HF in the audience. I'm sure that there's plenty of people here that know way more about it than I do. As Jim said, I'm a computer science professor in the electrical engineering computer science department, and that's my training. So a lot of people in the department keep thinking that I'm an electrical engineer, and it's because usually electrical engineers are the ones that are the experts in the RF field. So why am I talking about it? It's mainly because of what we were discussing just before this program started. I started out as Signal, but I switched over to cyber, and the new cyber branch stood up just a few years ago. And as a computer scientist and as a Signal officer, cyber seemed to be a natural fit to kind of slide into. And I'm at the Army Cyber Institute, and we're thinking about like future problems. And over the last 20 years, we have been relying in the Army so much on satellite for everything. And we've been fighting an adversary that doesn't really have much capability to jam our satellites, doesn't even understand it. But if we look at a future threat of our what we call near-peer adversaries, China and Russia, they have capabilities. They have electronic warfare capabilities, and knocking out a satellite, either as we just saw with Russia shooting them down physically, or with using electronic warfare means, jamming is really not that difficult, because there's really not a lot of power. If you think about a satellite trying to transmit back down, it only has so much power it can transmit, and so the signal that comes back is fairly weak. So it's not hard to knock someone off. So the question becomes, what did the Army do before satellite comms? And we did HF. That's what we did, and it was slightly before my time. I think I did learn a little bit about HF when I first joined the Army, but it was kind of not. After 9/11, everything we focused on counterterrorism, and everything kind of changed after that. So thinking about long haul comms, and I'll use the term beyond the line of sight. That's really what we're talking about here. There's only without a satellite, there's really only one way to do it. We could debate over troposcatter, which is another method of going beyond the line of sight, but it requires a lot of power. But basically, HF is what we used prior to that. So what is HF? Just a quick background. I know plenty of you have probably seen this chart and understand it, but as I look at this, I'd like to just point out that the electromagnetic spectrum has some special properties depending on where you're at in it. So if you look in the center, you see center left, you see visible light. So that part of the electromagnetic spectrum is super critical for us to see. It's what we see around us. It's the light that we see. If you go to the right, you see where HF is. And HF is this only part of the spectrum that has this weird property that Marconi was not quite understanding and trying to figure out, was the idea that it bounces off the ionosphere. So that unique property is what allows us to do this beyond the line of sight communication. So this is another, I like pictures, so this helps kind of just describe the ionosphere is way up there, F1, F2 layer, and between 3 and 30 megahertz, when you transmit, you can get it, to refract back down, which can take you over a mountaintop or over a building or a town, depending on what your location is. And so this property is really the critical piece, because it's not like a satellite that you can jam. It's the ionosphere. It's a property of our atmosphere. So a quick history here on HF radio. So some of you are hams and see your normal Kenwoods and ICOMs, and I think that it looked like there was a giveaway for an ICOM at the beginning here they're talking about. So those radios I love, as a ham operator, I love operating those radios. But when I pick up one of these, I always get immediately frustrated because they're very confining. You don't just kind of surf around the band and try to find a frequency and then listen for a contest station or something like that. These radios are what I would call soldier proof, as I said earlier, because they're generally programmed one way, and then they try to make it where the soldier just has to press the talk and then it works. And so the real key protocol that makes this happen is ALE, which is automatic link establishment. We've actually got it at the Army Cyber Institute. We've got all 3 of these radios, which I'm pretty excited about. We just recently got the 160 within the last year, and which is the bottom one. So the 138 was quite old, I think in the 80s. We had that radio, and then the 150 is what's most common, I think, fielded right now, which does 2G and 3G ALE, and not to be confused with the 3G cell phone. It's just a generation, so the second generation, third generation of automatic link establishment. And then the PRC 160, which is the newest one, a little bit smaller, and it actually interfaces quite well with the computer. The 150 had a lot more difficulty in doing that. And all of these do ALE. And so what am I talking about when I talk about ALE? So people get confused about this. Sometimes they think that we're doing frequency hopping. With HF, we really don't do a lot of frequency hopping. In VHF, we absolutely do that, which is good for, it gives some jam resistance when you frequency hop. But really what we're talking about with ALE is just I hate to call it this, but it's kind of like a brute force way of establishing a link. So the 2 hurdles when you're establishing HF that you always have is frequency selection, and of course the antenna type and the height of it. So what ALE does is it solves this first part, because instead of going in and well, ham operators probably just listen and they hear a station and maybe get on a DX cluster and say, oh wow, this is I'm receiving this, so this is where we're able to talk to. Or sometimes you'll go on, there's a VOACAP, and I've gone on plenty of times to say, okay, what would be the best frequency to operate at this time of day? And it takes a while. It's not very user friendly, but you could figure it out, and you could say, okay, here's the ideal frequency for what we're doing. And I've done this in some of our testing that we've done that I'll show later in the presentation. But what you could do with ALE is you could just pre-program in all frequencies across the HF spectrum, and then what it'll do is it'll do this sounding, and it'll figure out, it'll try to connect to the other radio or the base station, and basically give a link quality assessment across each frequency. Then once that's completed, then you could just hit best call, and it'll automatically choose the frequency, and the soldier actually just sees channel number. They don't even see what frequency they're talking on. So they just see that it works. And that's really key, because if you think about, a spectrum manager, there's going to be specialized people that are going to have to understand the HF spectrum. But if you think about a soldier in the field that's just trying to make comms for the commander, they're going to be stressed out with a lot of other things. And so you need it to work very quickly and very well. And that's what ALE does. As you see, I kind of created this diagram at the bottom. I like it because it helps visualize what's happening when you choose these frequencies. So the top frequency is the 21 megahertz, and you see that kind of shooting off with the orange. It's a little bit small, but shooting off through the ionosphere, because as you go up in frequency, you're likely to penetrate the ionosphere as you use like VHF and UHF with satellites. You don't want it to be absorbed or refracted. When you hit the sweet spot frequency, then that one comes back down, which in this case I have listed as just, these are just frequencies I've just made up here, 5.25. And then as you go too low in frequency, then you could possibly just get absorbed completely. So it's really critical. I'm going to mostly be talking about NVIS communication, which is near vertical incident skywave, where you're really, you need all the ionosphere bouncing you can get, because you're going to be going up at a very steep angle and coming right back down. Okay, so antenna types. And as I mentioned earlier, I think Frank could probably give a better presentation on antennas here with his incredible setup. I was able to, I used to live in Maryland, and my sons were in, I went to a soccer place that must be nearby his house. And I remember the first time I saw it, I was like, holy cow, what is going on over here? But he's got a lot of neat towers, which you see on the far right with the Yagi. Those aren't technically field expedient. In the Army, we have to sometimes set up in a very a short time, get something ready to go, and communicate, and then move on. For NVIS communication, we're typically looking at a dipolar inverted V, most likely inverted V, because it's just the easiest to set up. But there has been some research, and if anybody knew Dave, Lieutenant Colonel retired Dave Fiedler, he was a big HF proponent. Just before my time, I think he retired probably when I was being commissioned. And he's the one that devised this idea of saying, well, if you want to do NVIS communication, you could just take a whip on a Humvee and you can tie it down, because now you have it parallel with the skyline, which is what you need to get that angle to be so steep to go up to do a NVIS communication. So it's really, really critical. And I think this is the part of the HF renaissance that we're finally getting to, because for the last 20 years, all the Army does is like, well, just put an antenna on it and start transmitting. For VHF, that works. For vertical antenna, you're ready to go. But actually putting some thought into, where am I trying to communicate to? How should I set my antenna so that it gets the maximum power there? That is really like an essential piece that we have to train on. It's not something that you're going to be able to push an easy button on for sure. Okay, this is the part that's super exciting to me. Is as a computer scientist, I love the digital aspects of this, of radio in general. When we go back to the early times, you have what my old NCOs used to call it the rat rigs. You had these radio teletype, which was back in the 20s, and that was obviously the Navy. They relied probably more on HF than the Army does for long haul communication. And then really you started to see in the 70s AX25, which came from the X25 protocol. I think it's amateur X25. And that was packet radio. That was my first introduction into digital radio. I got this little Baypack modem and had an old computer that I was able to connect to DX clusters and some BBSs or bulletins places back when I lived in Texas. That's why I have the 5 call, by the way. That was really cool. And then Bob Bernenga actually kept that alive by creating the APRS network after that, which is still like very widely used today. Then about the time I was graduating from West Point, Phase Shift Keying came out. I didn't have an HF radio at the time, so I wasn't quite into this at the time. I definitely got into it later on. PSK is a really cool protocol, but if anybody's ever operated it, they'll probably realize that it has no error correction. So you definitely get some weird things that happen with PSK 31. You'll start to see a sentence and then it'll kind of get garbled sometimes, and then it'll come back again, and that's just the fading that happens on HF. So if we look at the military side of things, we have the ALE uses MFSK frequency shift keying. So the 2G standard was in 99, and the 3G standard was in 2011. So that's kind of a critical thing to think about. when I hear people say, "Oh, HF is like old school comms, Cold War comms," is what a lot of people refer to it as. And you know, yes, it was used in the Cold War, but it doesn't mean HF is Cold War comms. You know, this standard, this 3GLE, if anybody here's operated it, we've I know that there's a few people here that are probably Mars operators, and we got the chance to operate that in Noble Skywave this past year. And really, what's cool about the 3G standard is it's got all these other modes. So once you make a link to a station, you could say, oh, I'm just going to do digital, or I'm going to do digital voice, or maybe it's a rough link and I'm going to go to a low data rate digital voice, which maybe sounds a little more digitized, but it'll still work. One thing I think is kind of fun to play with too, if you ever get a chance to operate a 3G ALE on a Harris radio, is there's a thing called LDV, which is last ditch voice. So basically, if you really can't make the contact, but you need to send a message, you can still, basically it records your voice and it sends it almost like a voicemail. So it'll sit there and slowly, over a very low data rate, send it across. And then once it's received, then it'll play it back for the other user. So those are the advances in the military, and obviously the most recent advances. And I got the privilege to listen to Joe Taylor speak at our local ARL Awards, regional awards this past, actually last week. So it's been a great week. And he created the JT65, and then eventually what caught on fire was FT8 in 2017 that got released. And now, if anybody here ever turns to 14074, 7074, you hear that the whole thing is just crowded with FT8 stations, just making a lot of contacts. It's a really, really cool mode. So I like to present that as just to show that, and I do this in our Army meetings as well, saying, hey, you know, there's still advances being made. The ionosphere hasn't changed. The computers have gotten much better, and the digital encodings have just gotten to be amazing. So so that part, I think, is critical for people to understand that we're moving forward in HF. It's not something that's kind of stagnated. And the next thing I want to talk about is the back end of things. I remember, you know, the internet started becoming a big thing around the time I started my military career, and the question became, you know, what's the purpose of HF when you could just now do a voice over IP? I mean, look at us right now. We're all talking over the internet, all in different places across the U.S. You know, what's going to happen to HF then? And I'd like to point out that the internet actually can help. And this is the part that's just super fascinating. The internet can help ham radio now, because now we can record and we can also locate where signals are going to. So if anybody hasn't done this before, this is the other part of FT8 that's super fun. If you think you have an antenna problem or a power problem and you're not making any contacts, you can always go to the pskreporter.info, and you can see if your signal is being received. In this case, all of these stations are stations that receive my signal either from when this screenshot was taken, either 2 hours ago or 27 minutes ago. So each one of those minutes is when that station last heard me, and they reported it to the reverse beacon network. So that to me is just another fascinating aspect of just collaborating these two means, the internet and HF, to be able to determine, you know, what's going on. It's a super fun thing if you want to really play with your antenna to make a transmission, make a modification to your antenna. Now you can go back and see, what did that do? What different stations received me now? So what a great tool, like great instant feedback, not just kind of hoping for the best and hoping you're making your transmission. You can now see what your antenna is actually doing and how well it's performing. The next thing I have to say is the bandwidth issue. So one of the reasons why, you know, if HF had super high speed bandwidth, I don't know if we would be so concerned about doing satellites, because satellites do provide the bandwidth, but HF can't provide that. So we have to acknowledge that is the fact that you could do some data, but you're really looking at digital voice. You could do like email. I know some of you probably have done WinLink before. I've got a chance to play with that, which is super cool. So with that, it's important for us to not just make sure that our soldiers are trained on how to operate HF and how to set up an HF radio, but we've got to also train our commanders. We have to tell our commanders, look, when your satellite is cyber attacked and you can no longer communicate, there are other means to communicate, but you're going to have to think about the way you're going to communicate. Do you really need to do a VTC with the general to see his talking head on there? You really don't. What you need, though, is you may need to say, do we take this hill or not? Or my unit's at this location. There's very small amount of data that could be critically important in a battle, and that can still be passed over HF. So it's important for us to be able to know when we have an acronym called PACE. So it's primary, alternate, contingency, and emergency. HF generally falls in that contingency emergency. But when you operate your PACE plan, you say, okay, now we're in emergency comms. You also have to change the way you command and control. At that point, you have to realize you're not sending, PowerPoints. You're going to be sending just text across. So a little bit of training that we have to do on our end to be able to explain that to commanders. Now, that being said, there is one example I have that's super cool that we've done some testing with, which is what if we tried to just abstract away the HF link completely? And so we did this this use case with John Rosico from NVIS Communications and Graham Kyle, and what they did is they used a Codan radio, which does do a 3G ALE, and they had this thing called the Android Tactical Assault Kit. So one of the very important things that the Army has to know is, where are my units? And we call it the Blue Force. So where you'll hear probably the term Blue Force Tracker. So where are my units at right now? And if their satellite goes down, then they need to do probably VHF. If they can't do that, then they need to do HF. Now, to abstract away that HF backbone, what they did is they showed an example of all of this is passed over this cell phone, over this Android Tactical Assault Kit, using either Wi-Fi, a local access point that connects to, or actual cell service. And as those units and stuff are moved, if there's a backbone that's the internet or some other high-speed satellite link, if that goes down and we have HF to fall back on, think about what the data has to be transferred. It doesn't have to be this map. The map's already loaded on the phone. What has to be transferred is, where's that blue dot? Where are my units at? And so sending over just a unit designator and a grid coordinate is perfectly a perfect example of HF being able to do that. That's very, very easy to do because it's just a small amount of data, but it gives that visual picture at the end, and the user doesn't even have to know that we just switched to HF on the back end. So this is where I think we're going to be going as far as employing HF and making it seamless and easy to use for the military. Okay. I've already mentioned this a couple of times, and I did take this from Ben Whitfield. If you ever really, really want to know HF, he just did his PhD in NVIS communication. He did his PhD in NVIS communication. It's I haven't gotten through the whole thing yet, but he's got. I did get a chance to talk with him at one point, and what a fascinating individual who's done some remarkable work in really understanding how to do NVIS communication. And so the next part of my talk here is I'm going to talk about some examples that we've done. Because, like I said before, if you think about it like a brigade combat team that's out in an area where there's obstacles in the way, their VHF comms aren't going to cover their whole footprint. They're going to need to use either satellite or NVIS communication. So it was discovered in the 1920s. The propagation was discovered during World War II as an essential means to establish communications in large war zones, such as the D-Day invasion in Normandy. So this isn't something new, and I've actually had people, when I've given this talk or talked about NVIS before, I've had ham radio operators say, well, what kind of specialized antenna do you need? And it's, a dipole is not really a special antenna, but a dipole can do that. And in this example, you can see the dipole is just transmitting straight up and then coming right back down. One misconception or myth of NVIS is people talk about skip zones. In NVIS, there's not really a skip zone, and I know when I've gone down to Penn State with Jim and Dr. Keith Lisiak, who I worked with, I think he recently retired. he was setting up these ionosons, which is a way to measure where the ionosphere is refracting your signal. Very fascinating piece of equipment. But it breaks that myth that people say that there's this skip zone. In NVIS, there's no skip. You can go 0 to 600 miles. You can go 15 miles. You can go 5 miles. In the case of the ionoson, you're going at a 90-degree angle straight up to the ionosphere and right back down. So there's absolutely no skip, and there's no missed coverage in NVIS propagation. Okay, so what did we do at Army Cyber Institute? We said, well, what happens when our satellites go down? Let's go to the place that we think is the most accurate example of a deployment. If anybody is from California, you probably know or you've heard of the National Training Center at Fort Irwin. And I would say after being deployed to Iraq, this is probably the closest to the way I felt in Iraq when I got out there. You feel quite remote when you're in this desert. The great part of this desert is it has this terrain feature called the Tiferet Mountain, which this mountain prohibits you to do VHF across it. And we actually brought our VHF radios, did some testing just to verify that we could not talk VHF comms across this mountain. So we went out there and we actually used commercial radios. So we got a buddy pole and Elecraft with an amplifier, and basically just did what can we do with NVIS, and what's the possibility? What is the data rates? What can we make work in this field exercise? So the places we set up was. I was at transceiver 1, which it's a little bit hard to read. It's at the top of the map here, and at the bottom are 2 different positions. So we went to 2 different places just to test this out. And what we did is we first started out with voice communication. So we started at 100 watts. We made voice comms. We saw that the VHF comms didn't work. Then we went down to 50 watts, and we were able to make 50 watts work. And as hams are supposed to do, and they don't always do this, is you're supposed to use just the power that's necessary. Usually people flip on their amp if they have it anyway. But we were actually interested in how low of power can we go, because if we have an adversary who's looking for us, we want to have short transmissions, we want to have small transmissions, we want to have low power transmissions, because we don't want to be we don't want someone to direction find us. So our goal at this point was, how can we go down to a very, very low power and make this work? And so we, after 50 watts, we were able to go down to 25 watts, and voice kind of worked, but it wasn't that great. So at that point, we switched to our digital modes. And as I showed you earlier, if you look at FT8, that was my first one to choose, because I was like, we've already tested this and it works really well. Let's see what we can do with it. We actually ended up using JS8 at the time because we wanted to send actual messages. So we did some JS8, and we were able to bring it down to 5 watts, then 1 watt, 500 milliwatts. And then at this point, I kind of lost my mind, but we went down to 100 milliwatts, and we were able to still close the link and send messages using JS8. That truly blew my mind. I mean, think about 100 milliwatts. That is a very, very low power to be able to go this distance. And you look at this distance and it's like, well, you're not really going that far. We're going 21 kilometers. Well, let me put this in perspective for you. If you were to map this and I put this into Google Earth, you see this, the transceiver on the left, the takeoff angle is on the left there. And the green in the center, I'll show you in this next slide, is actually below the line of where the transmission was. So this isn't an actual mathematical model. This is basic. All I did here was just put where the transceivers were, where the ionosphere is, and where you were coming back down to. So this takeoff angle is about 85 degrees. It goes straight up to the ionosphere. This is quite the distance. And then back down to the second transceiver. So 100 milliwatts to go that distance is very, very impressive. I was kind of blown away by this. I will say that in my disbelief, sometimes you get on the radio and it's kind of magical. You hear someone, if I get on the radio here and I hear someone from New Jersey, with all the mountains here in New York, I'm pretty sure I'm doing a pretty decent NVIS shot there. There's no ground wave that's going to get me there. But I'm only guessing, right? So to go further with this, we have this system called the Watchdog, and the Watchdog allowed us to do direction finding on the HF signal itself. So what we did is set this system up. It has four NVIS antennas arranged in a certain way, and it'll tell you the two cool things. One is the direction of arrival, which is important, the line of bearing, but it'll also give us the elevation of arrival. And as I said before, how did I know I was really at 85 degrees? Well, this actually told us in the top screen here. It's not the best graphical interface, but it's really cool what it does. But it's sitting here at 85.8 degrees was the elevation coming down from the signal. So with that knowledge, and if you know where the refraction point is on the ionosphere, you can actually pinpoint where a station is transmitting from, and that's what we did here. Super cool, because now it just confirmed that we were definitely doing a NVIS communication. There was no knife edge diffraction or something crazy happening that was allowing us to get over that mountain. We were truly sending the signal straight up in the air and straight back down. Interestingly enough, we couldn't get the Watchdog to DF when we went down to 100 milliwatts. It was just too much in the weeds. So that was a interesting data point that we had. Okay, I did mention earlier about Noble Skywave, pretty cool exercise. I mentioned this at our ARL meeting last week, is one thing that, and I know there's a youth talk later today, but one thing that they have done with this Noble Skywave Mars exercise, and I really think that ARL and the ham community should probably look at this as well, is gamifying HF communication. So they have a thing that's kind of like a capture the flag, where you have a live scoreboard on the internet, and as you make comms, you see yourself go up and down. What a cool way to get people excited about HF radio. The thing I was really excited about in this particular one is the winner for 0 to 150 watts was 10th Mountain Division, which was Sergeant First Class Robert Snyder, which one of our guys actually just went and delivered a Watchdog to them up at Fort Drum just this past week. Very cool for a Spectrum manager to be able to participate in this exercise and show his skills at operating all modes. It was a single sideband, digital voice, and 3G ALE, all of those different ones. And it's just really fascinating. This is where I say the Renaissance is happening, and this is a perfect example of it. We're doing some experimentation, but we're seeing active units that are actually out there doing some HF comms. And I will say that Noble Skywave, this is a contest to be emulated by the ham community too, because it's really a fun exercise to operate on, because it's not like you take your QSL logbook of the world, upload it, and wait like 6 months to find out how well you did. I think Frank doesn't have to worry about that, because I think he always wins with his station there. But this exercise, I think, is just fascinating, because even if you don't win, you can still kind of see where you're at, and you can kind of push yourself to make more contacts and see where everybody else is at, and compete with other stations on there. So very exciting. So I'll leave you with this. HF requires training and practice. One of the things that 10th Mountain has done is they don't go to the field and just say, oh, let's turn on our HF radio and start transmitting. They actually practice in garrison. They'll set up a network, and they practice before they go to the field, so they know how to operate. They have their plans loaded in their machines, or in their radios, and it's just that's really the way you have to do it. It's just not as easy as VHF. There's a little bit of thought you've got to put into it. As I said, it's less bandwidth, so we got to figure out how to make sure the commanders understand that. And it's really the only alternative to SATCOM. And the bottom pictures here I'm pretty proud of. Nolan, who's actually the cadet in the first cadet in the photo at the bottom there, he attended this back when we did this in person a couple years ago, and he's one of our star operators here. You see in the background, this is our HF, or this is our club room here. We have the PRC 150 is in the background there. And you can see an old Heathkit off to the left. We have a little antique station there with the Collins S line that people love to see that. And then on the left is the is our antenna setup. So we have the satellite array on the right, and then a JK mid-tri-40 on the left. We recently just put this up. There was a big building renovation. They had to take down our antennas from before, so we rebuilt pretty much from scratch. And I'm real excited because we have pretty much a state-of-the-art system. We recently got a flex radio with someone donated a Power Genius to us, so we have quite the setup. So when the cadets have time, they definitely have an amazing station to work on. And with that, I think I'm about out of time.